Welcome back, fellow NASA Hunt students and educators. My name is Miss Brittany Koger, and this is the final design phase for our microgravity dice game. I hope you guys have had fun with this project. I know I have had fun with this project. My students have had fun with this project. I have taught this project for 2 years now with my students here at Dade Elementary School in Trenton, Georgia. And I've seen so many wonderful designs for these game boards. I cannot wait to see which ones NASA chooses and what actually ends up in space one day. Remember, this whole game board is to help the mental health of our astronauts as they are on these long missions up in space. Think about being up in space without all your comforts of home. You're floating around. You don't even have your normal weight. You don't feel the same. It's completely different in outer space. And we want our astronauts to feel as normal as possible as we're looking at going into other planets like Mars. It takes 9 months to get to Mars right now. That is a very long time to be stuck in a small, confined space. You want to be normal and you don't want to just do research every single day and want something fun. So that's what this game board is about and this dice game is about. It's giving our astronauts some normalcy, helping with their mental health and helping them just to have a little fun. And I hope they do have some fun up in space. I heard games that they have that they've worked at playing and they do really enjoy just some rest time and some time to play a game and to have a little bit of fun because you got to feel normal, happy up in space. So for this station, you're going to need a couple of things. This is our design station. So if you do not have Tinkercad, which is a 3D printing program, which is absolutely free, and I tell you, that's one of my favorite CAD programs. I've worked on a lot of them. And this one is the easiest for younger students. If your students have never done 3D printing before, Tinkercad is so easy. It's so easy to set up for an educator. There are tutorial videos. YouTube, there are all kinds of channels where there are guys that's all they do is they work on Tinkercad and they show you how to make different things on Tinkercad. It's amazing. It is wonderful. It is broken down easier for our elementary age and middle school age students, especially if they've never used a CAD program before. If you do not have 3D printers, you can still have Tinkercad. And you can still use your designs from Tinkercad and send those into NASA. There's a little link under each student's design. It says Tinker this, and you can go to that link and pull it up and put it on your brochure that you'll send into NASA. Our final, all this information gets put into a brochure. Take pictures of your students as you're going through, so you can add those to the brochure at the end and just kind of show us what your students did as they went through these investigation stations. Right? So yes, we did weight and measurement. We tested several things with our magnets and with our dice, and we learn how dice naturally react and how magnets react through different materials and how thick our material needs to be. Now we've got to put all of this information on paper first. Okay, it is very important to have your students draw it out on paper, and I gave mine each a piece of paper. It's a larger piece. I wouldn't go too big, but a good 24-inch piece for each one so they can design things out. You're going to need a little bit of room to do that. Okay, so you're going to need a ruler because you got to make some good straight edges. Now, their game board, I told mine can be any size or shape they want it to be. I had some do ovals, circles, triangles, stars. The star one was harder to do with the magnets because they kind of want to stick together in those points. So that was hard. I went with a basic square. Okay. And I went with a square because all the sides are the same size. And on Tinkercad, my 3D printers that I have, I cannot go bigger than 6 by 6 by 6. 6 by 6 by 8. 8 is my height there. So, we talked about that with my students, but my students sat down and we designed this and we drew it out on paper. So that's what I'm going to do with you today. And I'm just going to kind of show you how I did all of that. Let me get my paper turned around. You're going to need some tools to write with. I'm going to grab a Sharpie so you can actually see what I draw, because on this paper you're not going to see it unless I actually show you that. All right, so get your ruler. Talk about a good size for a game board with your students. Think about rolling a dice. You don't want it to be too big of an area. You don't want a huge game board to take up a whole bunch of space. So my students and I, we talked about it being anywhere from 5 inches to 12 inches. That's kind of where I stayed in that box. You don't really want it to be bigger than 12 inches. I went with 7 inches today. I'm just going to draw out a square that is 7 inches on each side. And I'm just going to draw this out real quick. Let me get my Sharpie. All right. Don't make fun of my square now. With a ruler, it's a little bit easier. All right, so my length, how long it is going to be across from side to side, that's length, and that would be your X on Tinkercad. Your X is side to side or left to right, all right? So I always do those motions with my students. X is side to side, left to right. That is our length, how long our box is going to be, or our board is going to be, and we chose 7 on that. All right, Y is from front to back, and that's how wide it is going to be. How wide is our game board going to be? And I'm doing a square, so it is going to be 7. So I have a 7 by 7 square on my paper. Now, we got to think about a game board. It's not going to be flat. You want walls. Remember when we were rolling dice, we don't want our dice to bounce off, all right, and go in outer space. So the walls of this bowl that I rolled in was, I think they're 3 inches. Yeah, it's 3 inches in height. That is a good height. My dice did not bounce out of this, and I can still see in there and reach in there, and it's not too deep. So I chose 3 inches for my height, and I just went over here to the side and drew out a 3-inch line, and I put an H by it, and I put 3 inches. All right, so this is what I have so far. I'm going to show you. Don't laugh at mine. Don't laugh at anybody's designs. We don't want to do that. Be nice to each other. All right, so here is my 7 by 7 square, and then my height is over here, and it is 3 inches, and that's what it's going to look like. All right, so now that's my game board. Now, if I want to put on my walls, you want to say that you want NASA to be on one side, you want stars. You can put any kind of decoration on the walls and the sides of it as you would like. I'm going to show you one that I have here. This is one of mine that my students developed my first year doing this. This was their game board. And again, I cannot print anything bigger than 6 by 6 by 6. So this was actually printed with a NASA printer. Machina Hill, my NASA director, printed this for me. But notice it says NASA on it, and it's got little stars all the way around. And we were putting metal in the base and spherical magnet in their dice. So this was a really cool design. Design it however you want. If you want cool stuff on the outside of it, design it like that. Put cool stuff on the outside of it. You know, put your name on it. Put, you know, this logo, whatever you got, you know, put something on it. Make it look cool. It is your design, all right? Then what we're going to have to do after that is we're going to have to measure our dice. You can either go back to our weight and measurement station and you can find the measurement of the dice. I'm not going to tell you exactly what that was because I don't want you to cheat off me. I want you to go figure that out on your own. So you're going to draw out a dice and you're going to do some math and learn how to split it directly in half, all right? So you're going to measure that dice and say that my dice is a half of an inch, okay? That's what I'm going to say right here. My dice is a half of an inch. If it is a half of an inch, what's half of a half of an inch? Anybody know? That would be a quarter of an inch. All right, so we would split our dice in half, and it would be a quarter of an inch. All right, so and then I'm going to draw out this little dice here, and I am splitting it in half. So if you see this mark, this halfway mark, that's what that is splitting it in half. All right, so this is saying that this is a half of an inch, and split in half. I'm going to draw a line off of it. That is a quarter of an inch or 1/4 of an inch. All right, so see that? I drew that out right there, my little dice, and I'm going to split it in half. Now we got to know about the spherical magnet or the ball bearing that is going to go in it. So you'll go back and you will get that information from that little ball bearing, or you can measure it again here with your group. I'm not going to tell you the size of it. I'm going to fold my sizes down so you can't see that. I don't want you to know that. I want you to figure it out. But then just kind of trace that little metal ball. And so you can see that that's going to go inside of your dice. Then you're going to take this plan and you're going to put it on Tinkercad. Like I said, if you've never worked with Tinkercad before, take a few moments to teach your students how to use it correctly. Go into the tutorials, go to YouTube, Google, whatever you're making. There is on this slide presentation, there is 2 videos, one showing you how to make a dice and one showing you how to make a box. It's just a basic box. So taking a basic shape and making it what you need and hollowing it out, and it shows you how to do that correctly on Tinkercad. Like I said, even if you don't have 3D printers, I encourage you to use a CAD program because that is our future, whether you see that or not. They are 3D printing houses. They are 3D printing food. They are 3D printing, I know this sounds really weird, but they are 3D printing body parts, ligaments and things like that that can be made with muscle tissues. I don't even know how all of it works. I've not studied all of that, but I know that is something that is getting into the future is 3D printing. And that is a very big network that we have coming up for our students and that you could get into. So I hope you guys have fun with this. Measure it out, draw it out, make a blueprint, put your blueprint on Tinkercad and work from there. And like I said, you can copy those links from Tinkercad and put it in your brochure that you can send into NASA at the end of the year. I cannot wait to see all of your designs. I'm so excited for this NASA Hunch Academy. I hope you guys had so much fun with these stations. Always look to the future and look to the stars and keep your mind thinking beyond and where we can go beyond where we're at now for our future. All right. Thanks, guys. I hope you had a wonderful time. See you later.